This statement provides two necessary conditions for a number to be divisible by other. 1. Quotient obtained should be an integer, this can be a positive integer, or a negative integer or 0. 2. Remainder should be equal to 0, so when I distribute 30 apples among 6 children, each of the children get equal integral number of apples, 5 in this case, this is known as quotient, as well as I am left with 0 apple, this is known as remainder. By same logic, if I distribute 0 apple among 6 children, each of the children still get equal integral number of apples, 0 in this case, and I am left with 0 apple, this is known as remainder. And so we say that 0 divided by 6 is equal to 0. Consider another case. I have now 33 apples, and I want to distribute these apples among 6 kids. I may divide it in two ways. I first distribute 5 apples each, and then distribute the remaining 3 apples by cutting in halves. So quotient obtained equals 5.5. 2. If I distribute 5 apples to each of the kids, I am left with 3 apples. This is the case when we obtain remainder. Quotient equals 5, remainder equals 3, basic framework of remainder. Different cases. When n is a number divisible by 7, it can be written as 7k equals n, where k is the quotient. 2. When n is divided by 7, remainder obtained is 3. It can be written as 7k3 equals n, where k is the quotient. 3. When n is divided by 7, remainder obtained equals 3 is equivalent of saying remainder obtained is -4, when divided by 7. It can be understood that when n is divided by 7, remainder obtained is 3 implies n is 3 more than a multiple of 7 implies so n is 4 short of another multiple of 7. So remainder obtained equals -4. 4. When divided by 8, different remainders obtained can be equals 0, 1, 2, 3, 4, 5, 6, 7, 8 different remainders. Similarly, when divided by 5, different remainders obtained can be equals 0, 1, 2, 3, 4, 5 different remainders. 1. Remainders are additive. It means that remainder can be obtained by breaking down a number in 2 or more than 2 parts and then finally calculating the resultant. 2. Remainders are multiplicative. It means that remainder can be obtained by breaking down a number in 2 or more than 2 parts and then finally calculating the resultant. Wilson's remainder theorem. If p is a prime number, then p-1. 1 is divisible by p, in other words, remainder obtained when p-1 is divided by p is prime number, equals -1, for example, remainder obtained when 4 is divided by 5, remainder obtained equals -1, remainder obtained when 6 is divided by 7, remainder obtained equals -1, remainder obtained when 12 is divided by 13. Remainder obtained equals -1, corollary to Wilson's theorem. If p is a composite number, then p1 is divisible by p, except for p equals 4, relationship between remainder and factors in case of a polynomial. In case of polynomials, we are not required to find the remainder by actual division. By using factor theorem, we can find out the remainder without actual division. Although we should know the method of synthetic division, which is at least better and less time taking than actual long division method. Synthetic division method. Synthetic division is a shortcut method for dividing a polynomial by a linear factor of the form x, k. To write the dividend, we need to take care that we write the powers of variable, starting with the highest one, in descending powers and insert zeros for any missing terms. What is the remainder when the polynomial p, x, equals x to the power of 4, 3x squared 1 is divided by x, 2, step 1 start with writing 2, after putting x, 2 is equal to 0, value obtained of x equals 2, on the left-hand side and coefficient on the right-hand side as below. Step 2 write coefficient of x to the power of 4 att the bottom. These values written below second line is the result that we will obtain at the end as below. Step 3 multiply 1, inside circle, by 2, that we have written on the left-hand side, as below. Step 4 add the value above first line, 0, and the value between first and second line, 2, and write the result below second line as below. Step 5, next multiply this 2 written below second line with 2, written on the left-hand side, as below. Step 6, add the value above first line, -3, and the value between first and second line as below, 4, and write the result below second line. Step 7. Next multiply this one written below second line with 2, written on the left-hand side, as below. Step 8, add the value above first line, 0, and the value between first and second line, 2, and write the result below second line as below. Step 9, next multiply this one written below second line with 2, written on the left-hand side, as below. Step 10, add the value above first line, 1, and the value between first and second line, 4, and write the result below second line as below.